Famil Tech.
Hi guys, welcome everybody. I hope we civil engineers must know what is area moment of inertia and how it is related with the buildings and how it is related with components and also in designing some parts of the components or designing whatever it may be, designing the footing or beams or slabs, everything comes at some point of the designing. There comes a point in which we have to include the inertia point in some formulas or whatever it may be. So I hope it's very good. It is very really better to know what it really is, what a moment of inertia is. So let's go into it. Today let's see what moment of inertia is. We basically know the formula for moment of inertia is I is equal to b d cube by 12. First of all, what moment of inertia is? Moment of inertia is something that is related to stiffness. So let's keep it as moment of inertia as MOI. It is a property that relates to stiffness. So property of stiffness. So this is the first point. It is linked to stiffness. Then what is stiffness? Stiffness is nothing other than some rigidity. The more the component is stiff, the more rigid it is. So the more moment of inertia, the more the moment of inertia a component has, the more stiffness and more rigidity the component also possesses. So the moment of inertia increases and also stiffness increases. This is a practical thing, and let's study with related to this formula. We all know inertia is equal to bd cube by 12, for which this b stands for breadth and d stands for depth. Okay, this is the main formula, and we know the numerator, it is a multiplication between breadth and depth. So the more the depth or more the breadth provided, it will automatically increase the moment of inertia as it is in the numerator. If it is in the denominator, if some components or if some numericals are in the denominator, it will surely reduce the value. So but here it is in the numerator, so it will surely increase the value of moment of inertia. And also specifically, when compared to breadth, the depth will increase the moment of inertia more, because it has the sign cube in its depth. So if you just provide a 3 meter as a depth, it will give 3 to cube. 3 is a 9 and 9 3 is a 27. So the value is increasing rapidly. So let's just, I'll give you a example. Let's keep this as beam. So these are the reinforcement provided in the beam. So let's have two categories, first and second. First with stiffness more, and second stiffness less. So this tends not to bend. This will stand rigidly. For this, let's take example of steel or wood, and at the same time let this be rubber. So this tends to bend if we press a rubber, if we compress a rubber on either of its length. What will happen? It just bends. Okay, let's think a column provided with rubber, and if you go and stand on the column, what will happen? Just it will bend and it will fail. At some point of time, it starts to tear, it starts to yield. At the same time, if you stand on a wood or something made of something, some components or some material which are stiff, which are more stiff, what will happen? Just will take the load and transfer the load through its own body towards the ground. That's the thing here. So it also a concrete is more stiffer compared to It's more stiffer, not compared to all the materials. It's somewhat stiffer. It's enough for transferring the load from the top to bottom. So that's why we are using a concrete, which has more stiffness. That is the thing. So what moment of inertia has to do with that? So I'll hope you will be understanding it better if I show you an example. Let's take a cross section of a beam. This is the cross section of the beam and the dimensions of 4 meter by 4 meter. This is the first thing. And let's take another beam which has the same depth, that is 4 meter, but has a different width. Let's take it as 6 meters. And let this be the second example of the cross section of the beam. And I'll also show you a third example of the beam which has more depth but same width, which is 4 meter, and the depth is 6 meter. If you compare between the third example and the second example, just a small, very small difference, that this has been rotated 90 degrees, just rotated. Let this be both. Let all these three be a concrete beam made of a mixture of cement, whatever aggregate it is. It is just a concrete beam, but all the dimensions are different, getting different either on the side. So let's see here. This is 6 meter, that's width is 6 meter, and also the depth is 4 meter. So we know the formula for finding the moment of inertia. Let's implement in these three types of beam. So in this case it comes as, let it B and dq by 12. This is thing. And if you see for this kind of beam, the width is 6 meter and the depth is 4 meter cube by 12. And come to this thing, this section, the breadth is 4 meter, 6 meter, that is the depth, and 12, 4 6 cube by 12. So if you differentiate, if you find what the answer is, it is like 21.33, and this will come around 32, I guess, and 32, and for this it will come around 72. Okay, just see the difference between the inertia, moment of inertia of the first section, I of second section, and I of third section. Just see the difference. It is increasing rapidly for the section which has more in depth. So let's conclude. A beam or whatever component it is with a large number of depth has more inertia. The more inertia, the more stiffness, and the same time the more stiffness, the more rigidity and the capacity to transfer the load without failure. For a better understanding, I have attached another example for you in which a man steps over a beam which bends when the breadth is higher and the depth is lower, and at the same time the beam tends to bend when the depth is higher than the width. So let's go into the video.